Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, the next speaker is Professor Pankaj Jalote. He is the director of IIIT Delhi, and he's also the founder of IIIT Delhi. And prior to that, he was at IIT Delhi, and then and I think before that, he was at IIT Kanpur. And his area is mainly in the area of software engineering. He was the head of the department in Kanpur, and he was a professor at, assistant professor at University of Maryland before moving back to India. I request Professor Jalote to come and deliver his talk, and I request all of you to maintain silence.
Okay, good morning, everyone. I know you're getting restless, perhaps close to lunchtime without a short break. So let me start with this. In Delhi, there is a very, close to my house, there's a very favorite restaurant I have for South Indian food called Saudi. Just 10 by 10, few tables. And every now and then I go there for my favorite. He has a South Indian platter where there is, you get rasam, you start with one idli, one vada, a little dosa, and 2-3 other things. So I thought I'm coming to heart of South India. So I've organized my talk like a platter. We'll give you a little rasam, we'll give you one idli, we'll give you a little vada, and hopefully you'll catch one of these, you'll like one of these, maybe all of it. So let me start with maybe papalam. So I have one slide. I'm going to first talk about my institute. This is really what I think and dream about now. And I want to share this. As Rick mentioned, I'm actually employee number 001 of the entire institute. So when we started, there was nothing but me. So I want to just take a couple of minutes to share with you. I'm hoping that in a couple of years, we'll be as large as this crowd with as distinguished people as we have here. But we started in 2008. It's a very research-focused institute with very strong focus on PG programs as well as undergraduate programs. Right? So we have now 32 faculty because it's a research institution. Every faculty member is a PhD from finest places across the world. And what I also want to share with you is that we have about 400 BTech students, about 100 MTech students, and we have 40 PhD students, about one of the larger PhD programs. And I understand we have one PhD student from Coimbatore Institute of Technology. And every now and then when I talk to him in the earlier, so how are you guys doing? I think he's the one who gives the craziest answer. He says, sir, I'm in heaven. So I don't know what to mean by that, whether we are really killing him or whether he's really enjoying it, but he seems to be really enjoying it. So if any of you are interested, get excited by all these talks and what Microsoft is presenting, get excited about doing research as a career, talk to me. There are 2 PhD students who will be giving their posters, and come join us. So that's my little rasam or papadam about the institute. So what's this talk about? The main talk, for which we have the title. So most of you will start your career, most of you perhaps will go and join as engineers. And we are talking from this side mostly as researchers. And researchers and engineers have often been different communities interacting, but not quite as much as I think they should. But what I want to talk about is that software engineers, the engineers, that job that you'll do, can also engage in research. Small research, but you can engage in research. I'll give you multiple examples of that from my own experience. So I'll draw upon my personal experience, having interacted with various companies, to illustrate the point that engaging with engineers, particularly if you have a researcher also around, can be really fruitful to do research as well. Right? So that's the reason and the topic of this talk. So let me take, since I'm going to draw upon my personal experience, let me take a couple of slides to just tell you about a little personal journey relevant to this. So my PhD was not in software engineering from Urbana-Champaign, but I shifted to, when I joined the University of Maryland, which was very strong in software engineering, I shifted to that because I planned to return to India. And I figured at that time, as it turns out correctly in hindsight, that software engineering is going to become very, very important for India, as the time has shown. And so I moved completely to software engineering in the 90s and wrote a textbook about it. So perhaps many of you might have studied this subject from that book. So are there some students who've studied this software engineering from a book that I've written? Any students? All right, not too many, not too many. All right, so looks like Anna University doesn't like my book that much, but that's all right. I took 2 sabbaticals while being a faculty member. 2 years I spent in Infosys as vice president, and I spent a year and a half in Microsoft in Redmond. So let me tell you a little bit about both of these as to what I did. So in Infosys, I went there with a line responsibility, a manager. So I was vice president quality, to head the quality department. It has a very, very functional responsibility. It is not supposed to be doing research or any such thing there, right? But as part of the job and part of what we were doing, because we had to talk to engineers about, look, this is how you're supposed to do good software, this is how you should architect it, this is how you should test it. I talked to engage with hundreds of engineers and project managers there. In 2 years I was there. But look at the academic output, the output that people like us look at. The academic output was a few good papers, I think maybe 4 or 5, that came out, research papers that came out of my 2 years there. At least one PhD problem that I identified while I was there, I took it back to IIT Kanpur, and then we had a PhD come out of it. Problem originated from my work there. I wrote 2 books which were written, published by Addison Wesley. Actually, they became quite popular, translated in Chinese, etc., official, with some royalties from Chinese coming onto this. And there's various other impacts. Personally, I had a wonderful time. I think I grew more in these 2 years than any other 2 years. But in any case, the main point I want to show is that I did reasonably good academic work while actually having completely aligned responsibility with no research component in it. Now, the second stint, Microsoft, actually went as a visiting researcher, but in Windows group, not in Microsoft research. Just to point out, it was in, again, a product group. As it turned out, the boss changed within a few weeks. Big companies have reorganizations, and I found suddenly that I don't have a boss. So the fellow moved, since I was a small guy coming from, individual coming from somewhere in India. Nobody sort of figured out who should I be attached to. So I was unattached. So I went around and met with a lot of people, right? And I was really concerned that no one should end up saying that, hey, look, this guy, this professor came from IIT Kanpur and just, spent a year goofing off and didn't do anything. So I was very concerned about that. So I would just go around and meet, what are you guys doing? What is your problem, etc., etc. As it turns out, in that short while, I probably interacted with most of the major groups. Certainly Windows was the home, but I talked to all of these people from Office, SQL Server, corporate, etc. Again, the academic knowledge, if you see, again, 5 papers came out of it, 5 different co-authors, only one of them from Microsoft Research. I think the other 4 or 5 were all people in these product groups. And all these, I can say now, was working sabbatical hours, which means you don't work more than 5-6 hours a day. Very luxury, right? Nobody has that luxury. I don't have it now. You guys are certainly not going to have it in your jobs. If you're thinking of that, forget about that. So why am I telling you about this? It's not to just tell that, look, as a researcher, you can, and as a faculty member, you can have a fun life as well. You can write books, you can write papers, you can travel, work in different organizations. That's also a side goal. If you want to be a researcher, you can also enjoy some of these kinds of things. But here is the main point I want to drive home here. And the main first point is that you can find research problems in most situations if you are looking for it. I get so many mails from students saying, sir, I'm doing my PhD or I want to do a project. Can you tell me a problem to work on? I think that's a it is in one sense a very hard problem. But I'm saying that you can find problems if you look for it. And I think these two stints I've shown, without having research really as a main focus, one was able to find out. And the other thing is that most of us will tell you, and you'll see, and when we talk about it, we'll position the research problem that we are working on, and then pose a solution and show how the solution is good. That's how almost all research talks are there. It leads us to think, and indeed that's how often research works, that you do identify the problem first and you sort of solve it. But what the other lesson I've learned is the alternative is also very effective. That is, you don't have a big research problem. You sort of go and solve some problems and then see what is the knowledge coming out and generalize it. Certainly at Infosys, there was no such concept of me trying to solve some research problem. We did things. We found out interesting things we did, and we generalized it and converted it to research. So I think this is also a viable way of doing research. It probably wouldn't lead to big research, but good research can come out of it, right? And the third, which is really engaged with the title of the talk, both of these are shown that whatever I was able to do was really because of engaging with practitioners. I couldn't have done it sitting in my office, in either Infosys or Microsoft. So engaging with practitioners is important. So if you are going to be a practitioner, in some sense, this can give you a sense of that you can participate in research in small ways while being a practitioner. It would help if you have somebody, some researcher to help you along, right? Now I want to drive home this point in another way. This is from personal experience. But I want to drive home this point from a little bit more sort of perspective, maybe slightly meta perspective. So I suspect many of you will end up as a software engineer in some company. So what is the job of software engineer? If you get some interesting project where you're going to write some code, then typically the your job will be to develop some software. And the interesting thing to note here is an engineer does not have total freedom. You have to develop software within some cost, within some time, with some quality. That's fundamentally engineering. You build solutions using knowledge within cost, schedule, and quality. There's some other parameters as well, right? That's the nature of engineering. So it has to work in that and has to be predictable. You can't have unpredictable engineering. Let me write this, let me develop this, and we'll see how it turns out. Let's build a bridge and see whether it's going to work out or whether it's going to fall or not. You can't do that. So very predictable. Now, what does software engineering researcher do? What is his job, his or her job? If this is what software engineer is doing, what is the job of software engineering researcher? Now, as I understand, people can debate on that. I think the software engineering researcher, not in general, the software engineering researcher, the goal is eventually to evolve methods, tools, what have you, to help software engineer do his or her job within cost, within quality, and so on. Right? That's the job of software engineering researcher. So the researcher is creating new knowledge, new tools, etc., which the engineer then uses to do his or her work. Right? That's the relationship. So it shows here. So that's the relationship. Software engineering practice, much, much bigger people. I mean, in India, we know, what, about 300,000, 3 lakh, or is it 3 million, I forget, or 2 million, whatever, 2 million. We have 2 million odd software engineers. Large population of engineers who are writing code, testing code, maintaining code, all this with predictability, etc. On the other hand, you typically have a very small research system, which is the software engineering researcher. I'm just calling that as a, all right. And the relationship is that whatever these guys do, hopefully, will produce knowledge that the engineering people can use. Engineers can tell the researchers, hey, look, this is the problem we are facing, can you help us? So researchers produce output that researchers themselves consume, and build more research, do more exciting work. And researchers also consume knowledge. Fundamentally, that's the goal which engineers will consume. In software engineering, science is a little different ballgame, right? So that's one point that I typically mention to students, that it's in some sense a pyramid structure. I put it in verse here, that you have a large number of engineers which is creating products which are even larger number of users. So what, 50,000 people in Microsoft or 20,000, whatever the number is, develop Windows, and then it's used by millions of people. So large number of users, thousands, tens of thousands of engineers coming down to using knowledge created by hundreds or maybe few thousands of researchers. So it's a very, it's a pyramid structure. So if you want to be in research, which is what I think TechVista is about, to excite you to do some research, then you need to be at this 10%, at this 1% of the population. If you're excited about it, then you should do research. All right, so the concern I have, to point this out, is that a lot of published research in software engineering, in my view, people can differ in that, in my view, does not provide direct help to engineers. It is feeding more on its own self. Okay? And so there again, the theme of my talk, that engaging with practitioners can really help, is I want to drive home this point that engaging with engineers through this particular route. All right? So this is my, if you wish, rasam, so whetting your appetite. So this portion is done just to, why am I talking about the problem, right? So this portion is done. So even if you've understood it, good. If you're not, you can still catch up on what I'm going to talk about now. So now I'm going to tell you a few ways how you can engage, a researcher can engage with practitioners, or how practitioners can engage in research. All right? I'm going to look at 2 or 3 approaches, and each one of them put in 1 or 2 experience that I have in particular. Right? So that's again, platter will show you a range of things. Okay, so now coming to first, which is the traditional method. A lot of researchers use it. Get data from projects and then do all sorts of analysis on data to get knowledge. People use data from companies, people will use data from open source software. Lots of papers will be using data from what practitioners will produce. Okay, so if you want to do this, and in fact Microsoft Research has very strong groups doing this. So I'm going to give you a few examples that I myself have used. These are all published work, so I can mention the name of the company easily in these kinds of things. All right. So again, the first work, this is from my time in Microsoft, was on component testing. And as you'll see, none of these works I could have done myself as a researcher sitting in my cabin. No way. So the way many of these products work, that a product is broken into multiple components, hundreds of components actually. Each component has its own team, developing it, testing it, and so on. Certainly 2 teams are always there, a dev team and a test team. And the test team tests its own component. So the goal, we started looking at data, how are the bugs being found in these components. So we started looking at that, and goal is to understand the relationship of how testing of other components helps a component. Now remember, again, I'm presenting to you as if we went in with this as the goal. So we were exploring. Much of it is retrofitting as to I'm giving you a problem and then explaining the solution, though it was really first attacking the problem and figuring it out and then sort of see that, hey, look, there is a general thing around it. So the interesting thing we found was, for a component, the defects that were being found by its own test team, by test team of any other components, by user testing, by application testing. All these are different methods that the company has. And we collected data. Now what's the interesting stuff we found? We found that the maximum number of defects in a component are not found by its own test team. but by other test teams. Now, after we found it, we went to all the people. They said, hey, well, look, I understand that. I can understand that. So they related to it. They understood it. But when we started digging further, we found interesting thing that for a component, only a few other components were finding most of the defects. So this is what we called as test buddies. That is, for a component, there are buddy components which are finding many defects in that component, right? And so this is the kind of thing we got for most of these components.
The number of test buddies for different components.
All right, someone is taping me and replaying it back to me, perhaps for some ulterior objective, or was it to keep you to make you silent? At least it has had that effect. So, so thanks. Okay, right. So we found, if you see, most of the components have of the order of 10, 15 test buddies, even though there are hundreds of components. So very interesting thing came out. If you think about it, there are obvious benefits of how you can do testing. So people participated and they can help themselves using this data. So instead of going out to hundreds of components, they can now go to 10 components, 5 components to help their own testing. So those who are into social networks, etc., social network of the kind that perhaps you are participating in, you can use the word buddies, components. So components have test buddies. So there's actually a social network getting formed of components. Components are making friends with other components for testing purposes, and you can do interesting social network analysis if one wishes to. So one example of how we were using data, understanding it, working with engineers to just make sense out of the data. There's a lot of work which we had to do to reach the simple charts. Now let's look at another project which we did, again with Microsoft, again a published work. So interacting with many engineers, with product groups, what we found was that when a product is released, let me show you the next slide. This is how the failure rate happens. This is actual data amortized in a certain way. Then you release a product, do nothing to the product, and you find that failure rate actually decreases over a period of time. This is actually inconsistent with all software reliability theory, fundamentally inconsistent. All software reliability theory, those of you who might have read it, is called software reliability growth models, which all work under the assumption that reliability improves as you remove bugs. Here, nothing is happening. So essentially, inconsistent with existing software reliability models. So this was the data. Now this is what practitioners are telling you. Now what do you do? So this is where I collaborated with the researchers from Cambridge. And then we basically took this, understood it, we created a model, and then we used all this data to propose a model, validate it, find out these parameters. So interesting model, we said there's something which will decay at a certain rate, there is steady state reliability, and there is a decay rate, and we were able to tie it with the existing reliability models as well. So fair amount of stuff we did, validated it using all the data, rich data that's available. And another interesting concept that we derived, that each product has a stabilization time. So again, intuitive, most people know about it. When you release a product, it takes a little time to stabilize. But we were able to sort of put some equations around it and show it there. All right. So now this is the first portion so this is, I guess, if I haven't used up VADA, so this was the VADA. So talking about how you can use data and how you can actually use the data, work with practitioners, and generate useful knowledge out of it, which you can publish and share with others, right? So now I'm going to move on to, and I gave you 2 examples. I have at least 3, 4 others from different companies. I just shared 2, let me now move on to the next step, perhaps the small mini dosa that comes in the thali. And this is actually, I find this is the most exciting opportunity for engaging with practitioner and certainly perhaps the most that a practitioner himself can do. If you're a practitioner, you can do some experimentation while you're practicing to create some knowledge out of it. So experiments, I'm sure you've done science experiments in your school, I'm sure you've done it in the college. What happens in an experiment? You control everything, you change one variable or two variables, you see some output and you see how they relate. That's broadly an experimentation. Control everything, change something and see how it impacts. Now experimentation in software is very, very expensive because building software is a very expensive game. So you can't really do experiments in software, but if you see projects, companies are doing projects after projects after project. Thousands of projects are done by each company every year. So can we use projects as experiments without sacrificing the project goals? So that's the challenge here, and what I'm going to show you that it can easily be, with a little bit of work, you can actually tweak the project a little bit and generate some useful knowledge out of it while continuing to do your project. Okay? So let's take an example from Infosys. And what was in one of their product groups, at that time, this was when I was there, they wanted to use what is called software inspections. And when you go, and we had all these trainers come in and train all the engineers in how to do software inspections. But when you talk to the engineers, why don't you use them? They will say, well, it doesn't apply to us. It's a good thing, but it doesn't apply to us. So we said, hey, look, this is a phenomenon which we call it not applicable here. It applies to you, but it doesn't apply to me because I'm different. My product is different, my project is different, and we are different guys. We do it differently. So what we did was, we did a little experiment in the product itself. Said, okay, you want to do it, let's not take all this published data, let's get data from your product and see whether it works for you or not. Very simple experiment. We took some program units, we pushed them once through inspection, we pushed them once through unit testing, we collected the data and we analyzed it. Very simple experiment, didn't cost them. A few engineers spent maybe a day extra, or something like that. Very little extra cost, still doing your work, little extra cost, and you're now playing with doing an experiment. Okay? So there's a whole bunch of knowledge that came out. We showed that inspections got more defects. We showed that, some effort analysis. We also showed the capability of error detection, what it works out. The net result, after this, they adopted inspection as part of their product work. So all these trainers we would get, and they'll say, no, we are different. We don't want to use it. And we did a small experiment. We also wrote a paper out of it. But we did a small experiment, and we find that all this entire product group actually started using it. A little example, this I did with SAP. SAP had given me a project to study global software engineering, and we took a very simple model. There is this pair programming. I'm sure some of you would have heard about it. XP, Agile, all these people talk about pair programming. And we tweaked the pair programming, and we said, pair programming is supposed to be two people working together. We will create pairs which will work separately. So we said global pairs is a team of two people, one sitting in India, one in US or whatever, in a different opposite time zone. And these two together will be treated as a single person. The project manager will not know these two different people. He'll say, okay, I need to give work. Here is this pair. I will give this work to this, except that since this is now one resource with two people, he treats them as macho resource, as a mega resource, which can work much faster than that. So his project planning sort of changes accordingly, right? So we had a fair amount of abstraction to keep it simple to the project manager. Project manager doesn't complicate his or her life, just does it and just sort of assigns work, larger pieces of work to be done every day. But this is a good idea. You can discuss it, but nobody will buy it. So with SAP, we did some actual work, and we did, so we assigned it, we tried it on a project in SAP, and we found some global pair between India and Germany, and we showed that it actually can reduce the cycle time substantially of the work that they were doing. Okay? And let me take this third one, which is probably going to be the most controversial, and therefore I would like to point out, it's again a work that is getting published. It was done in Bosch. I'm not an author. I only help them. I'm not an author of this, because as I said, you'll see that this is a touchy question. So what is Parkinson's law? Parkinson's law is work expands to fill the time. So if I give you an assignment, you will relate to that better. If I give you a small programming assignment or some assignment, and I give you 5 hours, you will actually do it in 5 hours. If I give you 2 hours, you'll probably do it in 2 hours. You can't, if I give you 5 minutes, you can't. But, so the work will expand, because if I give you 5 hours, you'll relax, you'll chit-chat, you'll do something, and then you'll take 5 hours. Now, if you look in software, where the manager gives work to an engineer and says, you will have to do it in so many hours, conceptually, the manager has an interest, because the manager wants everything to be done in the time that he is projecting. So a manager can theoretically say, hey, look, let me actually give, instead of 2 days, let me give 3 days. So I'm safer, because I know the person will definitely fill it in 3 days, right? So the tendency of a manager may be to assign more time than is needed for the work. And of course, for all of us, look, generally you give me more time, it gives me a little bit more time to work, relax a little in between. So the question these people wanted to ask is, in their organization, is Parkinson's law at play? Very hard, a very touchy question, so please, as I said, it's a very touchy question. Software engineers would hate it, project managers will hate it, but I can imagine an organization want to know an answer to that. So again, you engage with practitioners. I think these people talk to a lot of groups, explain to them, anonymize it to make sure that the management doesn't know about the names of people, etc., etc. All that stuff was done, proper messaging, etc. was done. But we did some experiment on 5, 6 projects these guys did. And very simple, is that whatever is the time, we'll reduce it by 1/3. But because they had studied, they found a lot of people were not just goofing off and taking coffee breaks and so on. They were often a lot of time was going because a person was waiting for some information from another person. And so they arranged a 15-minute meeting every day in the morning to clarify everything. This is like stand-up meetings in Scrum and so on and so forth. So they borrowed ideas from there. So reduce the time by 1/3, give 15 minutes for resolving all these things, and you go on to do it. So guess what? They found productivity improves by about 15%. So yes, full Parkinson's law is not at play, not the entire 33% got saved, but yes, there was some slack. An interesting thing they did, that there wasn't any appreciable change in quality, we did some qualitative feedback also. Were you overstressed? Were we pushing you too hard? Were you working in the night, etc., etc.? And they generally found that nobody was saying I was overstressed and so on. So interesting, very preliminary, very generalizable. I want to put in a word of caution. We ought, we shouldn't sort of say that software engineers are goofing off or any such thing. There is room for improving coordination to improve productivity, which is very important to companies in our country, because they are mostly in the service business, and productivity, the amount of work that per person can do, is extremely important to their business model. So what I'll do is, I had various examples which I'm going to skip. These are all meant to whet your appetite that things can be done just being while being an engineer. Few of you can get together and do some things and sort of analyze data, do some things there. So the third style approach of how you can engage with practitioners is just studying practitioners. That's my last point. Software engineers actually form a distinct population which has a very separate culture. So I talked to some of my sociologists, researchers, and sociologists and organizational behavior people, they have methods of studying populations to find out what is, just to understand them, and so you can support them. So what we started doing was, as project again we started doing, was to learn So we started with this question, can we learn from the guys who are doing very good work, productive people? Can we learn from them and find out how are they so productive? And see whether we can transfer that productivity tools, methods to other people. It's like some students are very effective in studying, and if we can learn from that and pass it on. By the way, I did that also in our institute. Just talked to the students, found out some methods, and tried to send it to those other students, right? So in any case, we started doing this, so I will not go in the details. But interesting thing is we grouped them into 2 groups, again anonymized, etc., etc. All that was done. Not so productive, productive, and started studying it. We would tape them, tape their screens, sort of take their logs and all sorts of stuff. And one of the PhD students from Bosch is actually working on this problem. And finally, to cut it short, what we found was there are indeed strong similarities in the non-productive people in their own group. There's strong similarities in the productive people, and there are dissimilarities between them. What we haven't yet done is, can you transfer these dissimilarities from the productive group to the less productive group? That's our next step. We haven't yet done it. All right. So what I want to do is to end here. So the main point I wanted to do, is to drive home, is engaging practitioners is a good route for doing software engineering research. It may or may not work in other areas, etc. But certainly it's a good way to do software engineering research. It will end up doing perhaps smaller hypotheses than bigger things that you can do, but it's a very sound way, and it can really make the outcome of this research is almost directly relevant because you're working with researchers, with practitioners. So the outcome is directly relevant and useful. I've discussed 3 frameworks for engaging with practitioners, what practitioners can themselves do, and what really wonderfully, if a researcher and some practitioners get together, what they can do. And the last point is really why I think this is an important thing for, in general, our community of software engineers and researchers to look at, is that this is an approach which I think is very sound for India. Because India is large software engineering population and very small research population. Our strength is in engineering software, not in software engineering research. That's where our strength is. So if we can leverage the practice, which is the biggest thing happening in India, then we can actually use that in far more effective way. I've found Indian companies tend to be fairly open about things. They are willing to engage in such kinds of activities. They also have a very, very strong culture of data collection and measurement. Something, because it's a younger industry as compared to many other countries, they have established that culture. So doing these kinds of things, if you want to do an experiment in your project, collect data and analyze it, far more possible here. And I believe if we actually pursue this in a larger scale, it can lead to a fairly unique kind of contribution in the software engineering research, which is not that prevalent because of the way research sort of works. So I think we do that even with a smaller research base, but with a large engineering base. If somehow magically we can put all of this together in some cohesive way, we can actually start creating a niche kind of research area, a research direction and approach in software engineering. So that's the last slide I have, and I think after this we have 15-20 minutes of Q&A left. Shall I continue standing here?